Yeah. Hello, everyone. Welcome to Software Test Automation Group Meetup. Today, we have come up with a wonderful topic around the chaos engineering. For those who might not be aware of this terminology, it's something very interesting, very important in current times. We'll go more deeper into the topic. And while Madhuri, our speaker, she'll walk us through most of it. And if you have any questions or comments, please feel free to put it in the comments section. Or those who are here in person, please feel free to raise your hands and ask the questions. But just be mindful of time that we should not be going past 7 o'clock. And people who are here in the surrounding suburbs, so we don't mind sticking around, like, after 1 year after the talk either. So for those who are online, please be mindful that we'll try to wrap up by 7. Yeah. So with that, I will pass it on to Madhuri, who's here with us. Madhuri, please give a brief introduction about yourself and then walk us through today's topic about chaos engineering.
Sure, thanks, Vikas.
That's right. Okay, I'll start again. Okay, I'll make it short. Okay. Hello, everyone. Welcome to Software Test Automation Group Meetup. Today, we're going to talk about chaos engineering. This is a very interesting topic. And without much delay, we will pass it on to Madhuri. Madhuri, please tell us a bit about yourself and walk us through what is chaos engineering and how AI is helping with it. Yeah.
Yeah, thanks, Vikas. Hi.
I think you may have to unmute yourself. Yeah.
Hey.
Hi, Meera. Yes, please.
Hey. Hi, Meera.
Hi, everyone.
It's a chaotic day today. Okay, and all right. Yeah.
Yeah. Hi, everyone.
And we'll just do one thing.
Can I bring full screen?
Can you hear me? Okay, let's hope I can hear.
Yeah, I can see the voice thing with
Okay,
the.
all right. Okay.
Hi.
Yeah, it should be fine.
Hi, everyone. I'm Madhuri. I have around 14 plus experience in performance testing and engineering. I'm working as performance and automation test manager and MUFT as of now. So I'll be talking about chaos engineering. Again, I did not get an opportunity to implement chaos engineering in my organization. I've been recommending, but again, there were a lot of challenges. But with AI, there is a feasibility that more and more organizations can adopt. So that's something I'm going to explain on, how chaos engineering, what is chaos engineering, and how AI is enabling it to implement in a better way. Yeah. So this is the whole agenda. I'll be talking about what is chaos engineering and what are the principles, the fundamental practices that we go through when we do chaos engineering. And then we'll talk a bit about AI, what is AI and what is generative AI. and then how this AI can enhance the chaos engineering practices. What are the benefits of having AI being integrated with chaos engineering? And then I'll show a quick demo from Gremlin. Gremlin is a tool that we can use for chaos engineering to create chaos, to do a CPU attack, memory attack. So there are various scenarios that you can go through with Gremlin. So there are a lot of tools to do chaos engineering. But again, Gremlin is very user-friendly, but again, it's a licensed version. So we have other tools like Chaos Monkey, and with AWS services, we have FIS as well. Yeah. So I'll go with the introduction to chaos engineering. So what is chaos engineering? Like, what do you all feel? What is chaos engineering?
You inject different kind of, I not say defects, but you inject different kind of volume interdependencies within the production system. Because I've done chaos engineering on production systems actually, not in non-prod. So, and you need to see the system behavior, how it performs. So for example, let's say you have a New Year day sale, you want to mimic that thing, to inject that chaos within the system in prod, and let's see how your system is behaving, right?
Yeah.
That's that. Which I've done.
Yeah.
I've implemented a lot of chaos.
Yeah. That's right. So in a layman terms,
Basically inducing faults,
faults, yeah.
basically shutting down system or
Yeah.
probably removing some table
Yeah.
to see that the whole system doesn't come down.
Right. So chaos engineering, chaos. What is chaos? You're creating some kind of chaos. You want to do some kind of disruption. You want to break the system. That's chaos. And engineering is something where it's a discipline. Like, you want to do the task in a controlled, planned manner. So that's engineering. So that's chaos engineering. You're breaking the system wantedly, but in a planned, controlled manner, in a controlled environment, wherein you have to ensure that once you break the system, you should be able to recover it back to the way it was. So that's how we define chaos engineering. Yeah. So with chaos engineering, like, as you mentioned, the core idea of chaos engineering to replicate a real-time scenario. But again, having said that, you can do that during performance testing or engineering phase as well, replicating the real-time scenario. But again, what is the difference between a performance testing, engineering, and chaos? Is that during performance testing, you go with a positive scenario. You want to replicate a production-like scenario wherein you are trying to measure the throughput or response time, the performance of the system in a positive scenario, right? But again, coming to the chaos, you're wantedly breaking the system, and then you're monitoring on what is the recovery time for the system to come back to its state. So that's the difference between the performance and chaos engineering. So in layman terms, again, if you go with functional testing, you have positive test cases and negative test cases, right? Positive test cases is something I would say performance testing. Again, negative test cases you go with is chaos engineering, where you go and do a destruction to see the worst case scenario so that you can avoid the risk in production. Yeah.
Similar to failover testing.
Failover testing is also a subset of chaos. Yes.
Subset of failure.
Yeah, because with chaos you can do a lot of things. Failover is one of them.
Okay.
Yes.
She was so bright. It feels so good to be back together again. Thankfully, we did something simple years ago to protect our family financially. In case the worst did happen, we got real low.
Okay. I was thinking they are asking some questions. Yeah. So the metrics of chaos engineering, the primary metrics are MTTR. MTTR is the mean time to recover a system. So that's the main metric. That's the whole objective of chaos engineering. So you're creating an outage and you want to see if the system can overcome, like, it can recover back. For sure, that we will get errors because you're wantedly breaking the system. We will get errors. But how gracefully those errors are handled is what you want to look at, right? And again, you will have the connection drops as well. But again, what is the percentile? What is the throughput that you would be achieving when you break a system is what you would be looking at. Yeah. Any questions? So these are the fundamental principles that we go with for chaos engineering. So the first stage is steady state. Yeah. So steady state is where you try to understand all of the components involved in your architecture. Well, you try to understand the normal conditions and you can get the baseline. If these are existing systems, you can get the baseline from the production, and you also define the threshold values for each of the metrics for that component. And then coming to the hypothesis. Hypothesis is the most critical phase within chaos engineering, where you come up with the use cases. What different kind of assumptions, like all failure points will be defined in your hypothesis phase, and also what is expected out of that failure and how do you simulate that failure is what you would be looking at during hypothesis phase. So you have to come up with your, similar to test cases, you have to come up with your use cases on what are different failure points. And then you have to come up with the outcome on what is expected from that failure. And then the strategy on how to simulate or replicate that scenario.
You can have an example.
Yeah, I'll go through the example. And then you run the experiment wherein you do some kind of attack or a simulation, whatever you have to do, the simulation strategy. And once you're done, then you have to analyze your output. And depending on your output, the engineers might have to come up with a mitigation or resolution points. So I'll go with a quick example here. I've just put a very basic example in layman terms. So if you see here, you can see a channel, a UI, and then you have two load balancers, and then you have the backend servers, right? So both the load balancers here are in active mode, right? So here, coming to the steady state. So what we've discussed is that steady state is nothing but to understand the component and the normal conditions of the component, and also come up with the baseline numbers. So here, the steady state is that the load balancer is in active mode, and the baseline metrics. The metrics that we are considering here is the CPU utilization, the throughput, and MTTR, which we've discussed, the metric. So CPU, these are all assumptions. It's an example. So CPU here is 60%, throughput is 300 TPS transactions per second that you're trying to achieve. And then MTTR is 20 minutes. Coming to the hypothesis. So as I've mentioned, this is more of an assumption on on various failure points and also what is expected when that failure happens. So here I've mentioned an hypothesis. So you have various different possibilities of hypothesis. So I've considered one of the scenario. Here, if one of the load balancer fails, what should happen? Right? If one load balancer fails, all the load should come back to the other load balancer. But what happens when the load comes back to the other load balancer is that user experience will be bad. You might have a bad user experience. You might have drop in the connections, and you might get error messages. So these are my expected output. Coming to the experiment. So how am I making this down? Right? How am I creating this outage? I'm using Gremlin tool. I'll just increase the CPU to 100%. And when the CPU goes up to 100% in this load balancer, it goes down. So this is the experiment.
So
right?
What do you mean by CPU 200?
CPU utilization, right? So using Gremlin, so I'll just show, this is the demo from Gremlin portal.
So can't you just go
The structure issue you showed, right? The exact example that you should, because is it on a cloud-based system or?
No, that is a basic
Basic one,
example.
yeah.
I'll just put cloud-based system. I'll come to that. It's a
Okay.
complex architecture.
Okay. Yeah.
Yeah, because for the beginners, it's always good that we go with basic. You understand the concept. Once you understand the concept, then you can go with the architecture. Yeah. So when I say CPU, so we have two load balancers, right? We want to make one of the load balancers go down, right? So how there are different ways to create an outage. So the outage I'm trying to create, this strategy I'm going with is
Can
to
you
do a CPU
configure
attack.
so that
Correct.
all the
So
buttons
how the
work?
CPU increases is one of the way is to inject a lot of load, right? You inject the load so that CPU consumption increases. But you don't have to do that. Using Gremlin, you can just configure it and the CPU goes up to 100%.
So all
And
the load is diverted towards just one.
I'm not even loading the system. I'm not even using any simulation tool. I'm not using any load runner, JMeter. I'm not using any simulation tool. I'm only using Gremlin. So if you see here,
So in Gremlin, you have to mimic the architecture of the application and then
you don't have to do anything. You don't. What you have to do in Gremlin is that you have the agent machine. For example, you have a certain host wherein you want to create an account. Attack where you want to do an attack. So you have to install Gremlin agent on that machine. So once you install that agent, it will have the communication, right? And then you configure it and then you can choose. Yeah. If you see here.
And this will be more like a server-side setup.
Yeah.
Yeah. Where
So
you
this
pretend
is Gremlin tool. This is Gremlin.
It's a pay tool.
It is a paid tool. Yeah, it is a paid tool. Right. See, this is Gremlin. I can open, I have an account. You can get a trial account for 30 days. You can just register and you can get the trial account. But again, to add in the agent machine and all, you need to have access. So I can't show that. But here, this is the tool. This is the way it looks. So here in this demo, they did not show how to configure the agent, but you have some team settings. You can go there. You can have a configured file. You can download it and put it on your machine wherever you want to do an attack. And then you can use it. So here, you have to choose the host, whatever you want to target. And you can select on what you want to do, what kind of attack. You have CPU attack, you have disk, you have IO memory. Again, you have state, network, you have various options. Whatever attack you want to do, you can select and you go to that attack. And then you can put the duration of the attack here. For example, if you want CPU to be 50%, right? How long do you want CPU to be 50%? Half an hour, 30 seconds, whatever is the time, you can put that time here. And what is the percentage that you want? Your system, what is the consumption you want to go with? So if you want to go with 50%, you can put 50% here. You can go with 50%. And is it all cores of CPU? That's something you put it here. And then you can run the attack. And you can see here, once you run the attack, that the CPU here is 0 here now, right? So it will go to 50. Here it's increasing. You don't have to simulate any load here. Generally with performance testing, we have to simulate the load. Only then the CPU utilization will go up. But here it's going up. And you can see the graph as well on how it's growing up. So if you see here, the CPU has gone up to 50%. Right? And if I configure it 100%, it will go up to 100%. And once it reaches 100%, your server will go down. That's how you're creating an attack using this tool. It's very much user-friendly. You don't have to write any code, but if you use other tools You have open source tools as well, like Kiosk Monkey, wherein you have to put a lot of code. You have to know Python language, where it's not that straightforward. Yeah, but this is a licensed tool where it's user friendly and it's very much straightforward, as you all have seen. You all don't have to put any code in it. Yeah. So here it's increasing to 50%. So once it increases to 50% here, as per the example I was trying to explain, the outcome was that the time to recover was around 30 minutes and they were getting 404 errors, right? So again, for any application, you shouldn't get an error. That's not the right way a developer should design an application. You should get some of the other error message saying you can wait, or like in some graceful message. So that's something they can go back and configure. Yeah.
What would you define as recovery in this case?
Here your system had gone down,
My
right?
machine is offline because we.
Yeah. So first time you get a failure, right? So here, when all the transactions have been moved to the other load balancer, there might be some transactions in between which have lost. So you might get the first failure, the user might get the first failure. From the time that you get the first failure to the time that it will recover and all the transactions will start going to this load balancer is what is your recovery time, where you don't have any connection loss. You have all the network traffic moved on to this load balancer.
If it is on Prime, like if you take on Prime system, right? What they do is they just go and add additional rack servers. That's what they do.
Yeah. If it is
I mean, I'm talking
active
about-
passive
yeah,
mode,
active
if
mode,
it is
they do
active passive mode, then it's like
In
you don't
cloud,
have an.
If you don't have shield, if you don't have,
Yeah.
assuming if you have AWS shield, if you don't have shield enabled, they will just
Yeah.
think it's an attack and they'll block you completely.
Yeah.
So if you have to do this kind of thing, we did that. That's in the thing. You have to get involved. You have to get the cloud involved, and then do the attack, right? Otherwise, they'll just block you right away. They'll think it's an attack, right? Like,
Yeah. But if it is a managed service.
Yeah, if
If it is managed service. Yeah. If it is not a managed service, if you are in control, then you don't have to. Yeah. So this is a very simple, basic example on how chaos engineering works. And
I have a question. What is engineering here? Like this is basically we did a chaos testing, right? What is engineering here?
yeah. So again, when I say engineering, whatever you're doing is in a
Process.
very controlled manner. So it's not straightforward. Like, I gave a very small basic example, but again, you will have a lot of prerequisites. It's not just about going and doing a test. You have a lot of prerequisites. You have to engage all different teams, and it should be in a very planned manner. Some people call it as a game day, which is really very critical day, because you do this testing on production. So production is not something you go and do your normal testing, and you should recover it back to the state it was.
Yeah. So
Yeah.
for that to happen,
It's
other
more of in a
stakeholders are
planned,
involved, right?
disciplined. Yeah. You need to have all
All the
different stakeholders involved. That's where it's not straightforward. And if you've already done hypothesis, is the most critical
So we did
phase.
this in Amazon.
Yeah.
Back in 7, 8 years back when the Prime Day was being launched, so that was the first time we
Okay.
did this.
Yeah.
We did this on production. Right?
Yeah.
So that time I was in Amazon, so we were actually trying to route the traffic, like when we get, and it was not only one, right? There's only one very view. You have zonal traffic. You have.
No, yeah, I'll show you. I'll
Yeah,
show
you-
complex architecture
you
also,
can do
where
that.
you will
I
go
don't wanna
months.
steal your throat.
Only hypothesis itself will take months for you.
Yeah.
Only hypothesis.
So-
Yeah, experiment is better than hypothesis. Yeah, that's the most lengthiest and complicated process. Yeah. So if I go back. Yeah, so this was all about chaos engineering. And any questions? All good, right?
Anybody
Yeah.
online, you can ask.
Yeah, and any questions from the viewers online?
I think they are in listen only mode, so should be fine.
Yeah. So artificial intelligence, it's every day we hear artificial intelligence. We use every day a lot of stuff like, uh, anyone want to explain what is artificial intelligence or like just the terminology? What is your view about artificial intelligence?
In a simplest form, how I understand it is gathering information, drawing patterns out of that, and then when a situation is encountered, you answer in that situation according to the information and the patterns that you draw.
Yeah, that's a data model, how generative AI works. Yeah. In layman terms, artificial intelligence is nothing but we just want to think. We just want a machine to think like us, to think like human, right? So the emotions cannot be imitated. However, the logic can be replicated. So that's what is artificial intelligence is. Again, artificial intelligence is not something new that had come now, but we know, like, from last few years, we've been talking about it, but this was there since 1956. It was there. But the thing was, it was all traditional artificial intelligence. It was weak artificial intelligence, which was completely dependent on the rules. It was rule based. So it was not using any patterns as such. But now with generative AI, as you've mentioned, it uses the patterns, it uses large data model, wherein if you have right prompts, you can get anything, everything. So the prompt engineering is very important here. If you know the prompt, you get everything. You don't need to know the code. You don't have to be a developer. Everything is
You
there.
need to ask the right question.
Right question.
I want to challenge that, but later partly. We'll talk later after that.
Yeah, but most of the scenarios, yes.
No, because like.
Yeah.
Anyways, so I'm actually working on Gen AI from last 1 year.
Okay.
So purely on generative AI, right? Like,
Yeah.
so I challenge.
Yeah, at least from my point of view, yes, the coding, whatever you don't know, you can just put it in GitHub Copilot, you will get.
I've written up an article,
Yeah.
an interesting article.
Okay.
So there's a lot of challenges in that, but
Yeah.
we'll talk about it.
Yeah, of course, anything that a tool gives can't be, trusted blindly. You still have to have that
There's a lot of
intervention.
guardrails, there is a big concept around it.
Just like Sonar Cloud. It
Yeah.
tells you what's
Yeah,
the
so-
problem with your
yeah.
code, but then
Yeah.
doesn't mean that your system is going
Yeah.
to break because of that.
Yeah. Similar to your autonomous cars or vehicles as well.
But it's still
Yeah.
great.
Yeah, still. Yeah. Coming to the chaos engineering back again, and how AI can enhance chaos engineering. This is something I found when I was trying out. So that's where I wanted to share this. So as we've been discussing about steady state analysis and hypothesis. And hypothesis, like, when I was recommending in my organization to do chaos engineering, hypothesis was the main thing where I was not able to understand or explain them on how you go with hypothesis. Right. But again, with AI, I felt it is very much easier and you get all possibilities of use cases and you will also know on which is the priority one is what I felt. So I'll just go here, as I mentioned, some theoretical details on the chaos engineering. So in traditional chaos engineering, so engineers develop hypotheses for potential system failures based on their experience and intuition. So that there's no guideline for hypothesis as such. It all depends, it all varies on how you think, right? Similar to a test case, how you think a negative test case, right? But again, AI can take hypothesis generation to a whole new level, right? So machine learning algorithms can analyze historical system behavior and identify patterns that human might miss. This can lead to more targeted and intelligent hypothesis generation. Yeah, so this is something we'll look at.
Also, you're using AI to generate the hypothesis.
Yeah, so this is something I've done. So yeah. So this is my Copilot. Again, this is just Edge AI. If you install Edge AI, you will get this.
Oh, this is Edge one.
Yeah, Edge AI Copilot. If you install it, you will get a Copilot by itself. So Yeah, so here I'm just giving a prompt saying that provide hypothesis. So you can give your architecture, whatever your architecture is in your organization. I will copy paste this architecture. So this is the architecture, right? This is again a complex architecture. This is not straightforward, like, the way I've shown earlier. So you have a lot of systems here. So these are all AWS systems. You have a lot of components here. So this is the architecture I'm going to give. And I want hypothesis for all of these components, right? So if you see here, this is the hypothesis for API gateway latency. This is a hypothesis. Introducing latency in the API gateway will degrade performance of entire system. This is the failure point. And this is the scenario. And this is expected output. And how this is the simulation strategy on how you create that failure. So simulate increased response times in the API gateway. So this is one of the hypotheses, but you will have multiple, lot of use cases. So you can get various possibilities as well. You can put one more prompt saying that give all possible hypotheses for API gateway. It will give all different scenarios. But again, this is more important because you will not be able to understand which one you have to go with. But again, here it will provide you the most critical one.
So Gremlin wouldn't work for hosted services, right? It would only work for if you own the machine, kind of thing, right? Or EC2.
No, not only EC2 instances. Any on-premise should also be fine.
Oh yeah, but like, so for a Lambda, it wouldn't work. For an API gateway latency, you can't use this. You'd have to figure out something else to do.
Yeah, it depends. If it is about simulating a scenario, you can use the load generation tools as well.
So for example,
For managed service, yes, it will not. So it depends. For example, I can just go through this.
Probably there'll be some other way if you want to
Correct.
play around with Lambda functions and
Correct. So yeah, that's something we'll go
discover
through.
that.
Yeah. So this is the architecture, right? So this steady state analysis, all the metrics and the baseline values, everything, whatever I put here is from AI. So I put a prompt.
If you don't mind, that's the previous one. Yeah, can you scroll down? Like it gave you for API gateway, which is good. It gave you for Lambda. What did it give you for MQ broker? Scroll down. Yeah, if you can go back to your architecture one. The picture, right, which you're showing. See, look at this. So MQ broker, right? So your Lambda is writing to MQ broker, basically it's posting a message, right?
Yeah.
But there is no connection between an MQ broker and S3 here.
Yes, but
Right.
there it has
And it just
mentioned.
made up things.
Yeah, it has mentioned. It has assumed that's something you have to
So that's
look
what I was
at.
trying
Yeah,
to tell you, right?
yeah.
So it just made up things.
Yeah.
That's
Yeah.
a good tester mindset.
Yeah.
No, it just.
No, that's right. So
Explain
you
it all
still
this.
have to go through what you get,
No,
but it will give you
interested
fair
to know.
idea on how
I was very interested to know, say, okay, MQ broker, how do you want
Yeah,
to do a chaos engineering on MQ broker?
Yeah.
Yeah, I think,
So
image
this is
one
not a
thing.
downstream system, but it said like S3 and impacting downstream services like S3 and DynamoDB. Yeah. So you can put all possibilities, you can put a prompt to get all possibilities, all hypotheses for this specific component. It will
gives you a direction, but then you still have to spend a lot of time.
not
including
so
time.
much time as in you do without this, because it takes a lot more time. Like you see, I'll just give you this diagram. How long will it take? Do you know, like, what is the system as well? Like,
It's
for
a good
example,
foundation, I think.
yeah, it
It's a
is.
good foundation.
Yeah, it is.
It'll be good, like if you can use this same thing and you deploy it on a open Azure model.
Yeah.
And make the temperature 0,
Yeah.
give you good output. I will do that. not cool.
Yeah. So yeah, this is something you can get. So here, this Excel sheet, whatever information I've put here is from Copilot. So all the metrics on what are the metrics you can go with for each of the component and the baseline values, the generic values. But again, if you have existing systems, you can go to production and get the numbers that's there. But overall, it will still reduce your time, your intelligence. It will give you a path on how you go. You will get fair idea on what you have to simulate and what your hypothesis would look like. And coming here, this is again hypothesis, whatever I've got from AI for each of the component. This is the hypothesis. For example, if S3 bucket hosting the static website, if this becomes unavailable, users will experience downtime is what is expected from this hypothesis. And then how do you do it? Is simulate an S3 outage and monitor the system behavior. So here, when you're creating S3 outage, you can't go with your CPU attack or memory attack, because this is a managed service. So it depends on every application. As I was saying, the strategy, the simulation strategy will be different. So it's not that for every component, you can go with a CPU attack. So for S3, you have to go with black hole attack, because it's like, it's more of network. S3 is a managed service, right? So that's how you have to go with. Again, coming to the API, gateway latency. So inject the delays into the API gateway and observe. So this is not through Gremlin. You can go through your simulation tool. So it's not that you have to go with Gremlin. It depends on your simulation
your
strategy.
requirement?
Correct. Your
Where-
requirement on how you want to go with.
So ideally, when you're planning for this, then how do you predict how long will all this be completed? Like,
That's what
Very
it's very
difficult, right?
challenging. Yeah, it's very difficult. And especially with hypothesis, it is very difficult to come up with the use cases.
And I think it's not only a developer or a principal engineer or
No, not
engineering
one
team's
person,
job.
not one
It has to
person.
be
All
product.
of them.
product
Everyone,
as
yeah,
well.
you
will
have to
define
coordinate, correct.
What your MTTR should be, depending on, all the finance, how much financial impact it's going to be.
See, same with performance as well, right? It's not straightforward. You have to sit with so many different people to understand
SRE.
what your NFR is. And most of the time with performance, NFRs are not measurable. They just give you 5 seconds.
Yeah.
So what is 5 seconds? They don't even know what is the logic within it, right? So it's not straightforward. But again, chaos engineering is more complex. It's a double to what you do in performance engineering. Again, with this tool, I found that with hypothesis, you will get a lot of visibility on what you have to do.
So by using Gremlin, how much you were able to achieve? Strategy, like simulation strategies.
It depends on your strategy again. If you want to do a simple attack, CPU memory, it is very straightforward through Gremlin. Because if you have to do a CPU attack, if you want to increase your CPU to 80%, say, you don't know how much load you have to inject. You should be injecting the load to see how it increases, right? But again, it's more of breakpoint test, like you have to break the
That
system.
you can do in Gremlin.
Here in
No, it's
Gremlin, it's straightforward. You can directly just put configure and it's done. Yeah, but again, as I've mentioned, and even the effort that you put as well. With the tool, you have to create your scripts and then you have to inject.
Monitor and see
Monitor.
whether it is reaching
Yeah,
that,
reaching
or
that,
not, like,
yes. And you don't know what is the load you have to put as well. You have to create that data.
Test
So
data,
test data.
biggest challenge.
So all that effort is involved,
Yeah.
whereas it is more straightforward to create that X through Gremlin. Yeah, because if you're going with load runner, same price you pay for load runner. So instead, you can go with Gremlin. But it depends. People don't have visibility as of now. Yeah, chaos is not done everywhere. I mean, whatever I've heard is that some people call it as resilience testing, and they do failover scenarios, and that's how they cover this. Yeah, but with chaos, it's not only about failover or a disaster recovery. It's more to it. You can do lot of various scenarios. It's more of creating a chaos through various different ways. Yeah. So then here I've just taken an example of S3 again here with Gremlin. So with S3, you can do a black hole attack. The way we've done CPU attack, it's just about configuring. Go configure your host, put your agents and enable them, and then do a black hole attack. So black hole attack is more of a network attack where whatever network traffic you're getting from one specific region, you're disabling that, and then your traffic should get redirected to another region, right? So that's what you're going to test here. So this is about black hole, S3 attack. And then even with the outcome, all this, whatever I've put here is from Copilot.
Okay.
Yeah, so I put what is the possible, scenarios, potential impacts that you would have when you do that S3 attack, right? So these are different, all possible scenarios. So if you have visibility on this, you can go and check all these metrics. Yeah, else it's not that straightforward. You might miss, for sure. And coming to mitigation, resolution as well. So what are the different scenarios, in case if you, you're doing a black hole attack and you have the load coming from a specific region. If you stop it, it should go on to a different region. So for that, you should ensure that you configure multi-region replication properly. You configure it in various different regions. So all these would help you to come back, to reduce the chaos in production.
So, Emily, what is black hole attack?
Black hole attack is more of a network attack. So if you have the traffic coming from a specific region with AWS, right, you have traffic coming from various regions. So depending on where your servers, what you select. So if the region goes down due to some reason, right, then your traffic should come from another region. It should move on.
Right.
Yeah, that's what you're testing there.
Okay.
The network traffic. Yeah. And yeah, so this is the strategy. So overall, with AI, for sure, I felt that it would give us the fair information on how to proceed, and the visibility on where to go, what the scenario looks like, what is that we have to do, and also good visibility on hypothesis and what the outcome should be, and what are the simulation strategies more of. Yeah. That's all.
Generally, like in like AI, you have put a picture into it, and it's calculating those stuff. But generally in banking, your AI is everything disabled in banking system.
Security,
Yeah.
right?
So you will not have access to AI at all in banking.
That is a question. Yeah.
Which bank?
Bendigo.
Depends actually. Other banks, no.
No, it depends. Or if you have any security concerns, then you need to have your managed service or some kind of
Data is moving out to
yeah.
That's why you host it on your own platform.
Platform, correct.
You host it on. See, that's what most of the OpenAI models are doing. Right?
Yeah.
You see even what is that AWS Bedrock. So they're consultants, right? What's happening today is if you have a Llama model, that's it. What they do is they say, okay, we sign up with not Llama is a bad example. Let's say OpenAI, right? ChatGPT, GPT 4.0, right? Now they tie up with OpenAI, and OpenAI is as a service which is hosted on Azure, right? And you can actually deploy your own model and you can test it. Let's say DALL-E 3, which is for images, right? Like we all so you can actually use Azure service, host model within that, and then play with that model, right? So that your data is kind of secure. But the challenge is about the guardrails, right? Like if you look at that image, right? Because you went back to the meetup is done. Sorry,
It's done.
deviating.
That's okay.
Yeah.
Which one? Image?
Yeah. So the image. See, if you look at this one model, right? They're using GPT 3.5, and behind that, there's an OCR model.
Yes.
So what it does is it basically bitmaps that image, right? And it tries to understand, okay, there is an API gateway. Now, what it does is behind it is actually a complex structure of vector database which is running. And what it does is, oh, you're asking a question, right? You ask that I want to generate this hypothesis, right? And it will see, okay, for an API gateway, what is the hypothesis? And we start making up. That's how it works. But with 4.0 model, it's a multimodal model. It's
much better.
You I think it started with GPT-4 Vision. 4 Vision was the better one.
So GPT 3.5 is backend.
This one, they got into 4 Turbo recently. Microsoft in the recent, I think 2 months back, they got into 4 Turbo. But yeah, I think the more like next year, I think by March when 5,
the latest version.
The 5, I think that's what Sam Altman is saying. The 5, if it comes out, the models are going to get cheaper. And you see more and more organizations moving into GPT-based stuff.
Okay, so we'll officially wrap it up. And then
Any questions if anyone
you can
is,
ask anybody.
if anyone is having any questions.
You may have to mute, otherwise there will be an echo.
For this, there's something called a spy, which I have.
Hello, everybody online. Like, do you have any questions, comments, anything to share? I know if you joined late, you might have a few important points. Okay. Yeah.
Hey, sorry, just a quick one. So the Gremlin is specifically for AWS. Is there anything for like on-prem or like multi-cloud stuff?
The chaos engineering.
Okay.
So the question is that can you use it for multi-cloud? Is that the question or?
I was asking more like so you're talking about Gremlin. And you're talking about So is that more just a cloud? Is more an AWS cloud or
you can use it for any infrastructure. You can use it for AWS, Azure, on-premise, anything. So for AWS in specific, they use something called as FIS, fault injection service. More of
Okay. So assuming there are no further questions, so anyhow, if you have anything more to ask, you can reach out to Madhuri on her LinkedIn profile. I'm happy to. You have all the details on our meetup page. Please have a look at it. And those who have joined a bit late, please fill up that attendance sheet. It is very useful for us to decide the future events. And if you're in Western suburbs, we look forward to see you all here. You can see it's pretty nice here. A lot of people have come in here. And then thank you, Madhuri. Thank you so much for that wonderful talk. It has raised more questions in my head than anything else. So we are happy to stick around. I think considering everybody lives around. So we'll stick around and ask more questions to you. Thank you. Okay. And thank you all for joining. I know it's Thursday evening. You joined in. Really appreciate it. And yeah, keep in touch. And then if you have anything to ask, please feel free to reach out to me. I'm happy to help you with any questions or queries and connect to the right people. Awesome. Thank you. Over and out. Have a good evening, guys.
Thank you.
So what I'm saying is,
Thank you all.
Thank you, everyone.
Thank you.
Thank you.